Okay, so good morning, everyone, and thank you very much for coming and for meeting. I know that for many people it's really busy days in June. The conferences started, so a lot of colleagues are also on business trip. But it's good that both sessions, both days, will be streamed online. So for these colleagues, it is also a possibility to watch the talks, and also it will be recorded. So that in future also the colleagues can get back to your presentations. And of course, these 10-minute flash talks will be just to give introduction to your groups, to give introductions to what you do. I will do the same with the strategy AV21, the program Space for Mankind, because it's really a huge program involving 12 institutes, 12 different scientific topics. So I will just make a brief overview of, let's say, the main projects that we are involved. And then I would like also to offer you here this leaflet you can take, and you can find some basic information about the program and visit our web pages where you will find more information. So this program started about 5 years ago with the aim to get involvement of the Czech Republic. Sorry, this is the place, right? To get the Czech Republic involved in important space missions and to enhance the collaboration between the different institutes of the Czech Academy of Sciences, but also with the universities, with the industry. So these meetings like this is really perfect for us to communicate across the different academic institutes, across the different research groups, and to find potential in future collaborations. So in fact, in the last 3 years, we involved as the Academy of Sciences into 8 new projects. We have more than 10 industrial partners, and we are thus involved in about 19 international space missions. And so this is the list of some of them, the main ones, which are the medium and large size missions of European Space Agency, where we got involved. And this is also the timeline. So you see that the space projects are, of course, the projects that are for very long period, long-term planning before we are getting actually to launch the satellites and to get to the data. So one mission that I would explicitly mention is the Solar Orbiter, because there are 10 scientific instruments. On 4 of them, the Czech scientists and engineers participated. It includes three instruments involved in collaborations with the Institutes of Czech Academy of Sciences, and one instrument also that Charles University was responsible for the Czech contribution. This mission successfully launched. It's on its way towards the sun, and it's providing the first measurements, and everything is going very well. Then further missions, well, ExoMars unfortunately is now halted because of the crisis just before launching the mission, and so hopefully it will be in future recovered. But then other missions include also solar system exploration, is large mission of ESA JUICE that will be launching next year, and that will visit the icy moons of Jupiter. And in the very long-term perspective, there are 2 large missions of ESA where the Czech Republic and Academy of Sciences is involved, are Athena, X-ray observatory, and LISA, the observatory for measuring gravitational waves in the universe. So the Solar Orbiter, I would just like to briefly show all Czech contributions that involve electronics, precise mechanics, also onboard software, and precise optics. Some of you were involved in these projects, and we will have also some talks during the day about some of these instruments. So the JUICE mission, as I said, it's just before launching, and will study the interactions of magnetospheres, but also will look at whether under icy crusty surface of icy moons there is the salty ocean, whether there are also conditions for life. And so that's very interesting mission that will get to Jupiter in about several years, so around 2030. And so the data will come at that time. So the Czech involvement also includes mainly the space electronics for the instruments and for the detections of the electromagnetic and plasma waves in the place. And then there is this X-ray large telescope called Athena, where there is a large Czech involvement in both instruments for Athena. I would mention this one, that is the X-ray integral field unit, which is the X-ray microcalorimeter that should have unprecedented spectral resolution combined with the high sensitivity. So it's a step forward in X-ray astronomy, which will allow us to get information about black holes, exploding stars, about how the black hole originated, about the hot plasma in the intracluster medium, how the large structures of the universe were created. And in this instrument, that is one of the most complex and most expensive instruments that ESA was ever planning for the scientific research, we will be responsible for part of the space electronics that will be reading the energy of photons coming to the detector. These photons will actually release the heat, and the amount of heat will change the properties of the instrument. There will be working in the superconducting regime, and this little amount of heat will just interrupt this superconduction, and from that it will be possible to measure precisely the energy of the photon, each X-ray photon that will come there. And then other ambitious mission, large mission of European Space Agency, is LISA, Laser Interferometry Space Antenna. This is the mission that will consist of 3 satellites, which will be 2.5 million kilometers each from each other, and will communicate by laser beam. And when the gravitational wave will come, one space direction will be enlarged and one will be shortened, and then other way around. And this gravitational wave will be detected by the delay of the laser coming from the other satellite. This is a very ambitious project that should discover the merging of supermassive black holes, and also then the origin, how these black holes were created in the galaxies. And to measure that, it's only possible in the space because you really need to have the long distance, 2.5 million kilometers, that is not possible to construct on the Earth. And we have gravitational wave observatories on the Earth that have like kilometer size. And these successfully measured the gravitational wave from collision of stellar mass black holes, and for that was the Nobel Prize of Physics given in 2017. On the hardware development, there is also the Czech contribution in this mission, which involves 4 institutes of the Czech Academy of Sciences. The main institute responsible for the hardware development is the Institute of Physics, Institute of Thermomechanics, and Institute of Atmospheric Physics for electronics. And the Astronomical Institute is doing mainly the science and developing the waveforms for what will be detected by these instruments. And the hardware consists in a mechanism for optical bench that will be working in such a way that will rotate an optical element, and by this very precise rotation it will be possible to choose one of the 2 laser beam sources. 2 are there for the redundancy, and so this element will be critical for LISA in case that it will be needed to switch between these 2 laser beam sources. So both missions, Athena and LISA, are just in the study phase that are trying to prepare the missions for the mission adoptions, hopefully during the next year. Okay, that's in the short time, that's all what I wanted to show you, like a just brief overview, flashlight of what we are doing at the Czech Academy of Sciences, but the involvement is much more, and there will be colleagues from the other institutes also talking about their projects, and that the institutes of the Academy of Sciences are involved. So thank you very much for your attention, and I don't know if you have any questions. If there is time, I will be happy to answer, or then during the breaks and during the whole conference. So thank you very much.